Hey there, welcome to episode 5. We're going to jump headfirst into the centerpiece of the demo game, the level scene, where the real fun begins. If you're just joining us, this is a series where we're showcasing many of the fundamental building blocks that are used to create Godot 2D platformer games. This is a beginner series and we're not creating the next AAA blockbuster game here. It's more about playing with all the building blocks and tools that are available to us and getting to see them in action in an oversimplified but practical way. If you've missed previous episodes, be sure to check out our development playlist on the channel. There's going to be 3 videos in this episode. In part 1, the video you're watching now, will explore the core building blocks of the 2D game world, the tile map and the tile set. We'll be using the tile set to form the backdrop of the level, and we'll shed some light on the world with different types of simple lighting and shadows. On top of that, we'll be adding a few more sound effects to set the mood. In part 2, we'll continue improving our game world by adding interactive switches, items, and upgrades. You'll see how we added power-ups and collectible items that enhance the player's abilities. And we'll look at other player switches and adding interactivity to the level and making it come alive. And finally, in part 3, we'll ramp up the excitement as we delve into hazards, enemies, enemy spawns, and the grand finale, the scripted boss battle. We'll unleash danger, spawning moving enemies and setting up simple encounters for the player to overcome. We've got a lot to cover, so let's jump right in. First up, we have player spawn points. We're using simple Node2D nodes to mark specific X and Y positions in our game world. In this case, we use one to mark where the player begins their adventure. It's a great way to experiment with different starting locations during development. When the game starts up, the player will be moved into the level layer at this position. We'll use Godot's Tilemap system to build our 2D side-scroller world. Using the Tilemap node, we can paint tiles onto the grid like using a paintbrush program. Oh, and heads up if you're moving from Godot 3 to Godot 4, you'll notice that several relevant properties have moved out of the tilemap and into the tileset resource. We could dedicate an entire series to the topic of tilemaps, but for now, we'll cover the basics. A tilemap consists of 2 crucial elements: the tileset resource that defines the available tiles, and the grid tile map that we will paint on. The tileset resource determines the shape and size of our tiles. In our platformer game, we'll use square tiles. You can also have multiple layers in a tile set that give you the ability to add some depth to your maps. However, we won't use those in our demo game. To add more visual effects to our tile set, we can also add different effects layers for different purposes. This allows us to assign more details to each tile in the tile set. Things like a collision shape and lighting effects can be controlled using these layers and allow each tile to handle its own lighting details. You can also add your own custom data sets to the tile set and tile map using these features. We'll use 2 main effects layers in our demo game. We'll use the collision layer property of the tile set to determine how 2D physics shapes will collide with the tiles. And we'll use the rendering occlusion layer on the tile set to determine how shadows should behave for the tiles. In addition to those layers, we also have the light mask on the tile set, to let the engine know how the tiles should receive and handle lighting effects. We'll look at those lights and shadows in more detail later on in this video. Let's look at the Tileset Editor in more detail. The DNA of a tile map is its tileset. The Tileset Editor is where you can configure tiles, set up regions and margins, and customize the tile data that will be available in your game world. You can then choose from the available tiles and paint them onto the tile map using this editor. The Tileset Editor can be intimidating at first, especially if you have a large number or differently shaped tiles. We're keeping things simple with a tile set that contains only 2 tiles, a simple empty tile and a simple full square tile. The first thing we need to do inside a tile set is add tiles to it. We generally have an atlas texture that contains all of the tiles in a single image, and we can use atlases like that to populate the tile set. In our game, we have an atlas texture, tiles1.png, that's basically just the 2 tiles, one solid and one empty. We've already added those tiles to this tile set, but here's how we did it. Since our atlas is a grid of images, we can use the region size, margins, and padding settings during the tile import to get the exact tiles we want. If you're using a different atlas with different dimensions, these settings can be adjusted to match your grid. Then we selected the tiles from the atlas and added those to the tile set. You can add as many tiles as you want from as many atlases as you want to populate your tile set. Once the tiles are added to the tile set, Each tile can be assigned additional information in their effects layers that we mentioned before. And here we'll add 2 important pieces of data to each tile. Make sure you're in Select mode in the Tileset Editor, and click on one of the tiles to see the additional data on the tile. For the Physics Layer 0, collisions are handled in the Select tab under the Physics section. Here we'll give the solid tile a collision shape that covers the entire cell. This means that the tile will act as a wall or a floor. For the Rendering Occlusion Layer 0, blocking light is handled in the Select tab under the Rendering section. Just like the Physics Collision layer, we'll give the solid tile an occlusion shape. In this case, it'll be a square that covers the entire cell. This will allow the tiles to block light and cast shadows. After the tiles are configured in the tile set with the appropriate layer effects, they can then be used to paint onto the tile map in the Godot editor. We only have 2 cells in our tile set, so making the level will be extremely easy for us. We can always add more complex tiles or change their settings at any time and place them into the game map as needed. And here's a little teaser. In the near future, we might delve into advanced features of the tile map system and maybe even create a separate auto tile tutorial for beginners. Stay tuned for that and let us know in the comments if it's something you'd be interested in seeing more of. Next up, let's shed some light on the game world using Godot's 2D light system. We already talked about basic lighting and shadows in a previous episode, but now we're going to expand on it using render layer names to make more interesting lighting effects. The 3 main node types to remember are Light Point 2D nodes make things brighter, Canvas Modulate nodes make things darker so that they can be brightened by the lights, and Light Occluder nodes that act like physical barriers that cast shadows from our light sources. By using a combination of these 3 concepts, we can make some interesting lighting effects with very little effort. Before we look at the nodes for those 3 concepts in more detail, and how they apply to our demo game, let's check the project settings and look at the friendly names we've given to each of the 2D rendering effect layers. We've named each rendering layer to match its purpose, and we've separated them out based on the type of object and if they represent a light or an occluder. The first layer is a default layer. For the simplest of games, everything can be on that layer, but we'll use these other layers to get some more complex lighting interactions in our game. The player layers representing lights and occlusion on the player node, the static layers representing lights and occlusion on the in-game objects, the tile map layer for lights and occlusion on the tile map tiles, and the background layer for lights and occlusion on the parallax background. We'll be using these layer names when we configure the lights, shadows, and occluders in our game. Using those names will make it much easier to remember what settings to use, and we can always add more layers if we need them. Okay, let's look at these 3 concepts and the nodes in more detail. The Canvas Modulate node can be used to add color tint to a canvas layer. We'll use these nodes to first darken our scenes to prepare those scenes so that they can be illuminated by light nodes. A canvas layer can only have 1 Canvas Modulate node on it. We've attached one here to the level scene. The important properties on the Canvas Modulate node are its color. To create light and shadow effects when creating shadows, this is usually a very dark color, but it can be adjusted as needed. And its light masks. These tell Godot which lights this canvas should respond to. Here are all the masks for the level canvas. Although it doesn't live directly in the level scene, we also added a Canvas Modulate node to our parallax background and to our player scenes. We'll be shining light sources from the level scene onto those scenes, so we'll use Canvas Modulate nodes to darken them first. We'll use these light masks for the parallax background, and these light masks for the player sprites. So now we have a darkened scene, and we can start adding in the light sources. The Point Light 2D node is used to create a light source that emanates from a specific point in 2D space. We discussed the basic properties of a light node back in episode 4, but as a quick refresher, the main settings of the lights are its texture or shape, the color of the light, the energy intensity, the layer ranges, the light impacts, how the light should cast shadows, and the visibility and light masks. In the demo game, we have 4 categories of lighting. Each category will use different settings to get different lighting and shadow effects. This is an example of a static light that is off when the game begins. The light can then be turned on when the player uses a specific toggle switch in the game. We'll go into interactive player triggers in part 2 of episode 5. This is an example of atmospheric mood lighting. This can be applied to highlight the game in the backgrounds with different colors. We intentionally prevent these lights from interacting with some layers. This is a similar example, but in this case we have light casting shadows on additional layers. Using this, we can create positional lights that cast interesting shadows and rays onto the game world. And here's a light that moves along with the boss projectile attack. More to come in the last video in episode 5 when we dive into the enemies and the scripted boss. Great! Now we have a darkened scene that's being illuminated by our light sources. But we're missing the final piece of the puzzle. Without this piece, the objects and the tiles in our game won't cast shadows. We'll use Godot's Light Occluder 2D node and the concept of light occluders to block light and cast directional shadows in our game world. Occluders consist of a shape, a list of lights that they will interact with, and a few additional properties that affect the way the occluder works. There are 2 categories of light occluders in our level scene. Earlier in the episode, we talked about the tileset rendering layer, where each tile in the tileset can be assigned an occluder polygon. This is how the tileset will interact with our lights and cause the tiles to cast shadows. Here is the square shape occluder used on our simple solid tile and the light masks it uses. We use an Area 2D node to represent hazard tiles. This allows us to place the hazards in spots that are not 100% aligned with the tile map grid. In addition to a collision shape, these hazard nodes also have a Light Occluder 2D node on them. This node contains a polygon shape that will block light and throw shadows. We use these light masks on our hazard tile occluders. For visualization purposes, we made the hazard occluder slightly smaller than the hazard sprite itself, so that it can cast shadows slightly differently than the normal tile map tiles. You can see here how the shadow for the red hazard tile starts slightly inside of the sprite, unlike the tileset tiles that cast a hard-edged shadow. By creating occluders of different shapes and by combining them with lights and light masks, you can make for some interesting effects with very little effort. So now we can create tile sets and paint tiles onto our game map. We can make changes and add different rooms and challenges for our player to overcome. And we can add different types of lighting to our game world, some static and some more dynamic, some that cast shadows and rays, and some that simply give mood lighting to the scenes. Let's finish up with a quick recap of sound and audio. We saw how to use basic sound effects when we talked about the player scene in the last episode. Now we'll look at the audio on the level scene. Just like the player scene, we'll use Godot's Audio Stream Player node and raw MP3 files to create the sounds. The 4 examples of audio in the level scene are the sound effect for the player trigger when they use a key to unlock a gate. It's a simple sound effect that exists as part of the player trigger, and we'll see more of those in the very next episode. The background music for the level. Here's the background music that plays during the level. When the level starts up, we begin this track, and we'll replay it on a loop to keep it simple. The music and sounds that are for the big bad endgame boss. We'll fight that big bad endgame boss in the last part of episode 5, and we'll show how we script the battle in that video. But for now, here are 2 audio components for the boss battle. The background music that plays when they enter the boss arena, and the basic sound effect of the boss breathing fireballs at the player. And finally, we have the victory musical score. The final audio component on the level scene will be the music that plays when the player reaches the star at the end of the game. This is another sound that activates on a player trigger, so we'll see this again in the next video. Don't forget to subscribe to our channel so you can get that episode as soon as it's ready. So far, in this first part of episode 5, we've learned some new concepts and expanded on concepts we've seen in previous episodes. We now have a basic understanding of tile maps and tile sets, and we can apply some interesting lighting and audio effects into our game world for different purposes. In part 2, get ready for us to add some text prompts, interactive switches, and items and power upgrades that can be picked up. We'll look at those and other player triggers coming soon. Stay tuned for more exciting game building blocks in our upcoming videos. Thanks for watching. Until next time, happy game developing.